Hey kids, welcome to lesson 2.3, calling methods without parameters. This is actually a pretty easy lesson, kids. We're going to take a lot of things we've actually been doing, tying them together just so we understand them better. What are those things? Well, one of them are going to be our methods, which are sets of instructions that define behaviors for all objects of a class. For example, in the turtle class, methods like forward and turn right give turtle objects the ability to move forward and turn right 90 degrees. To use an object's method, you must use the object's name and the dot operator followed by the method's name. For example, Yurtle forward calls Yurtle forward method to move a turtle object forward 100 pixels. These are called object methods or non-static methods. An object method must be called on an object of the class that the method is defined in. Object methods work with the attributes of the object, such as the direction the turtle is heading in or its position. Every method call is followed by parentheses. These parentheses after method names are there in case you need to give the method parameters or data to do its job, which we'll see a lot more in the next lesson. You must always include the parentheses after the method name. To me, it's always a bucket, kids, and whether you're getting water or not, you need to have a bucket. Coming down here, what we're going to do is we are going to write this code. Before we write this code, though, we want to make sure that we understand the order it goes in. So we just have to unscramble this to make the number 7. Lucky number 7, kids. First thing we always need, well, we need our public class, followed by our static void. Then we are going to set up our habitat. And then we are going to set up how big our habitat is. And then we need to make our 7. So our turtle always points north. So we want to go forward once. And then probably turn left and forward again. That's probably going to make some sort of 7. We need to show our habitat and the class and the main and the class. Well, that should be it. Let's see if we're right, kids. Uh-oh. What's wrong with that? Well, I got these backwards. Remember, we need to create the world and then what goes into the world. So remember, that order is very important. There we go. So after we put the mixed up code in order above, we're going to type the same code below to make the turtle draw a 7. We can always go into Replit, kids, but I think we can handle this in here. And basically what we're going to do is we're going to take this code right here and type it into here. Nothing too crazy. Let's go ahead. First thing we need to do is tell what we need to move. So we need Yurtle to move. We need our dot right there to show what we need to do. And we went forward first. And then after that, we got Yurtle to turn right. That was the second part. And then we got Yurtle to go forward again. Forward, turn right, forward. That should make it go. We got our habitat and everything. Let's see if that works. Oh no! What's wrong here, kids? Looks like I have another spelling error, as always. It's not Yurtile, it's Yurtle. Mr. Rhodes, Mr. Rhodes. And look at our turtle go. Well, we have some notes down here. Check code contains Yurtle, turn left, go forward. That's it right there. I guess that's a backward 7 now that I'm thinking about it. So again, kids, we got to make sure we understand the actual problem. So turn left, that's not right. We need to go over here. That looks more like a number 7 there. So there we go, kids. Make sure you are checking your work to make sure you are getting it correct. Well, now that that's done, we have a 7 Obviously, what's going to be next? 8. These number problems always bring up my favorite joke. Why is 6 scared of 7? Because 7, 8, 9. Waka, waka, waka. Well, let's get this going. We already have one command, kids. So now that I got Yertle forward, I'm going to turn right, I think. And that means Yertle should go up and over like the one above us. Let's just double check this, kids. Let's get this in a good position for you to see. So that has my turtle coming up here going right. We are going to repeat these commands. So this is going to go forward, turn right, forward, turn right. We need to do that. Well, we need to do that one more time here. So let's go over there. This habitat we need to get down there. Let's comment this out, kids. Let's start getting used to doing this. And this is going to be my top part of 8. So right now it's going forward, turn right, forward, turn right, forward, turn right. I need one more forward here. So I'm going to do another, ooh, look at the caps locks, kids. Yertle.forward, like that. That should take me right here in my turtle pointing that way. Let's see if I'm right. Look at that turtle go. That takes me right there. Now we can work on the bottom part of our 8. Bottom of 8. In this one, I'm going to have Yertle. Instead of turn right, how about we turn left? We're going to be efficient with our code here, kids. So that's going to turn my little turtle this way. Then I'm going to go forward, turn left, and forward again. Make sure we're writing in the right part of the code, kids. Oh, that could have been bad. We can copy and paste because you know how bad of a speller Mr. Rhodes is. That's one more of these. Should get us to where we need to be. So let's save and run. Look at that code compile, kids. Turtle should go there, there, there. Make a left, down, forward, up. Look, stopped right there, kids. That to me kind of looks like a number 8, a very boxy one, but the number 8 nonetheless. So that's all we did using our forward, turn left, and turn right commands. Procedural abstraction. Procedural abstraction allows a programmer to use the method and not worry about the details of how it exactly works. For example, we know that when we hit the brakes, the car will stop, and we can still use the brakes even if we don't really know how they work. Kids, we should all know how our brakes work. It is just 2 pieces of ceramic smushing between a piece of metal. It's been the same thing for hundreds of years. And if you recognize that word abstraction from APCSP, you should, because it's the same exact thing, just a little more formal of a title here. You will learn to write your own methods in Unit 5. In this unit, you should be able to use methods already written for you and figure out what they do. When we use methods for a class in a library, we can look up the method signature or method header, which is with the method name followed by a parameter list and its documentation. For example, here in a student class with the method signature public void print, which has empty parameter list with no parameters, methods are defined after the instant variables, the attributes, and constructors in a class. So constructors and methods here. That looks like what it is. So if we go down here, we have to pick those 2 things. Well, right here we have a public student. And if you look down here, we have our public string get name. kind of the same thing there. I think that's one of them. And then our public void print, that is definitely one of those. We got the student string names up there. That kind of ties it together. And that's our two method headers right there. Kids, I'm not going to go through this EIEIO on this video. This is really something you can step along on yourself, and I highly encourage you to. We will use this in class, but we are not going to cover this in this video. Methods inside the same class can call on each other using the method name. But to call non-static methods in other classes or from a main method, you must first create an object of that class and then call its method using object method name. So we have a little thing here, a little flow chart calling method from a main or outside the class, create an object and call object method. Inside the class, we just do method. So it looks like the difference here looks like the word object. What does the following code print out here? Well, we have a public class song. We have our print right there, and system's going to print out I like to. This is in quotation, so we're going to print out this exactly. And it looks like it's going to go eat, eat, eat fruit. Buckets all seem empty. In fruit, it looks like we're going to print out apples and bananas. So apples and bananas look like it goes in the bucket there. Under eat, we're going to print ate, and under new song, we just print that out. So I think we print out eat, we print out apples and bananas. So it should go eat, 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 apples and bananas. Don't forget the first part, I like to. So I like to, right there, eat, 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 apples and bananas. That looks like it, kids. And yes, it is. 2.3.2 Programming Challenge, Draw a Letter. Kids, this is going to be a warm-up here for our actual lesson, which will be in our next video, which will be drawing your name in Replit. So you're going to be able to pick your first or your last name. And this is just a warm-up, so do something easy. Again, we are just using the forward, turn left, turn right, and backwards ones in this one. Kids, I'm just going to draw the number 1 because I'm going to get you set up here, and I just wanted to make sure that you know how to set up the code. That's what I'm more interested in than your actual letter there, because once we get the setup going forward, turning left, that's pretty easy, but making sure this down here and setup is to print, well, that's a little different. So down here, let's take a look at our code. We have our regular things, our public class, turtle letter, and we have our habitat, which is 300 by 300. What we have to do now is to create another instance of our turtle. So we are just going to do turtle. And we're going to call it roads. And that's going to be equal to a new turtle. And where's that turtle going to be created at, kids? In the habitat we created up there. So if you look now, well, let's put one more line of code in here so we can see it. Let's just do roads forward like that. So this should create a turtle in my canvas here and then move it forward. There you go, kids. So that just moves it forward. The rest of it now, you are going to either move forward, turn right, turn left. Just as a little heads up here, kids, with the pen up, pen down, how that works. We've covered this before. Pen up, oops. Just literally think of it like lifting the pen off of your sheet. We can move forward. Then I can put a pen down. And then let's move forward. Let's turn right. Kids, I didn't put a semicolon there. And then let's go forward one more time. This should go nothing here, should move my turtle here, turn my turtle, and then actually make a line. So the pen up, pen down, we don't put anything in our methods or parameters here yet. We're not detailing anything. we're just moving up and down. So let's see if that works. Turtle moves, turtle turns, and we have our mark. So that's how the pen up, pen feature down works, kids. So when you go through it, that's how you can use this in order to make your initial of whatever. But remember, our next project's going to be your full name here, so don't go too crazy, kids, because that's going to be done in a separate video. To summarize, kids, methods are a set of instructions that define the behaviors for all objects of the class. Use dot notation to execute an object's methods. This is an object's name followed by the dot operator, followed by the method name and parentheses. That's move forward, turn right, stuff like that. A method signature is the method name followed by the parameter list, which gives the type and name for each parameter. Note that methods do not have to take any parameters, but you still need the parentheses after the method name. Remember the bucket, kids, even if you don't need the water. Procedural abstraction allows a programmer to use a method by knowing in general what it does without knowing what lines of code it executes. This is how we can drive a car without knowing how the brakes work. But kids, again, the shop teacher in me, you should know how your brakes work. A method or constructor call interrupts the sequential execution of statements, causing the program to first execute the statements in a method or constructor before continuing. Once the last statement in a method or constructor is executed, or a return statement is executed, the flow of the control is returned to the point immediately following the method or constructor call. This is just talking about the old McDonald song above. Null pointer exception will happen if you try to call an object method on an object variable whose value is null. That means it's not there. This usually means that you forgot to create an object using the new operator followed by the class name and parentheses. Kids, I do this so much. An object method or non-static method is the one that must be called on an object of a class. It usually works with the object's attributes. A static method or class method is one that doesn't need to be called on an object of a class. So those are some important vocabulary words, kids. Be sure you definitely write those down because they will probably be on the test. We're going to go ahead and take care of the AP questions on a separate video. So this is it for this video. I hope you found it useful as always. If you have any questions, kids, please let me know. Well, that's it for now. I'll see you kids in the next video. See you later. Bye, kids. Bye. Bye.